In this Choose Your Own Adventure lab, we were given the option to choose our own video to observe and objectives to pursue. I chose a video of a bullet speeding and impacting into a metal plate. I will use position data from this video to find the contact force of the plate on the bullet, find the kinetic energy of the bullet, and the change in kinetic energies, and we will find out where this energy goes. To do this, I will use Tracker, a CSV file, and a Python program using that CSV file. We will also use the momentum principle and the energy principle and Newton's second law and all that lovely stuff, and continue watching for more. So we'll start off with the tracker video. I'll start it off with placing the axes along the direction of the bullet's movement, just for ease of use. I then place the length scale across the diameter of the bullet. I know the bullet is a 50 caliber bullet, so that is 0.05 meters. I then took the position data from the bullet. As you can see, I did this multiple times. That is because the first and second times I was getting some wonky looking position graphs, so I decided to go with the purple one, which is from the position of the tail of the bullet, and I did that because that was the most easily visible within all the frames. As you can see from the position graphs 1, 2, and 3, the purple one is the most nicely shaped out of all of them, so that is the one I decided to go with because it is the most accurate, I believe. Now, from this graph we can see that there is a straight portion and a curved portion. The straight portion has a constant slope. We know that it's constant velocity, and from Newton's second law that means zero net force. Now from these frames we can see that the bullet is not being acted upon by anything other than gravity, which we can assume is negligible. It's not impacting with the plate yet, so there's no contact force. We're assuming there's no magnetic force or anything like that because we do not know of it. And so there's just a zero net force. So this is a fairly straightforward part. However, for this curved part of the graph, we can see from these frames that it is impacting the plate. That explains why we have a non-zero net force. We know that the slope is not constant, so the velocity is not constant. So that means from Newton's second law we must have a non-zero net force. And we can see that this net force is probably going to be the contact force from the plate to the bullet. Now, this is what we plan to find from the lab. So we're going to use this position data over here, put that into a CSV file, and use Python to solve this problem. Now we get our CSV file with the position data in the leftmost column. From this we're going to make our Python program. We initialize it with the mass and delta t shown here from the frames per second. Then again gather the position data. From that go to velocity, to momentum, to change in momentum, to Newton's second law, to F net. We also calculate the kinetic energy, and we're going to graph that kinetic energy and find the net force and all that. We've got some arrows to demonstrate that. But unfortunately, because the data just isn't accurate enough, this Python program doesn't do anything for us. This is kind of like how Dr. Schatz mentioned in Lab 3 that they specifically gave us data so that this would not be a problem, because they mentioned if the data is even a little bit off, it wouldn't work. So I made an Excel program to do this for me. I use these formulas up here to go from position to change in position, velocity to kinetic energy. We get this nice little kinetic energy graph. It slopes downwards. Kinetic energy decreases as velocity decreases, as you can see here. That makes sense. I also went from velocity to momentum to change in momentum to F net. Now this graph just doesn't make sense again because our position data just isn't accurate enough. Now if I had a way of accurately exactly showing the position of the bullet, I could probably get some usable data. It would look like this as the F net increases from 0 to non-zero, but unfortunately this just is impossible with this bullet position data, unfortunately. Now I will explain the results. We have this, from this bullet position data, we see that the bullet is smashing into the metal plate. We see that the velocity goes from constant to non-constant as our force changes from 0 to non-zero. That's the net force, by the way. And we can see that that is because the bullet is being acted upon by the contact force of the metal plate on the bullet, and this is causing the bullet to slow down. Now, we know from the momentum principle that momentum is conserved, so that as the bullet is slowing down, something must be moving. So the bullet is giving its momentum to the plate, and parts of the plate are flying off in different directions, and that is the momentum being conserved, as we can see here. The kinetic energy is also transferred due to our energy principle, that we know that's a thing. So we know that the kinetic energy must be given not only to the pieces flying in different directions, but also to the heat of the plate as the plate is deformed and it heats up due to the energy given to it. So in conclusion, we have gone from observations of video to being able to find forces and energies like we did in labs 3 and 4. We did this using Tracker and Python and Excel. And essentially, this is just why physics is really cool, because we can take a video of a bullet like this and learn cool things about it just by watching it and observing its motion. So, we found its energy and forces. Thank you for watching.